Now we have to find out moment of inertia of regular geometry. Okay, so first regular section, that is chosen as rectangular section. First we have to find out the moment of inertia of a rectangular section. MOI, that is moment of inertia, okay, of a rectangular section. Okay, first draw a rectangular section. This is a rectangular section whose width is B and the depth, that is equal to D. Okay, the CG of this rectangular section should be half of the depth from either side, the top or bottom. Okay, and the CG should be half of width either side from left or right. So the CG should be, suppose this is the CG, the CG should be at a distance D by 2 and this is at a distance B by 2. Okay, now we have to find out the moment of inertia of this rectangular section about an axis which is parallel to its base or parallel to its depth, which is passed through its CD. So this is the x-axis axis. Okay, and this is the y axis. Okay, the nomenclature is A, B, C, D. Okay, now consider a strip, small strip, that is PQ. This is a small strip of thickness dy. It has a thickness dy. Okay, the small strip has a thickness dy and parallel to x-axis. This strip is parallel to x-axis and at a distance y from this x-axis. So this is the distance, that is the y. Okay, now the area of the strip should be, area of the strip should be equal to width into thickness. The strip has the width B and thickness is the dy, dy is the thickness, so the area should be B into dy. Okay, now the moment of inertia of this strip about x-axis should be area multiplied with the distance. Okay, now moment of inertia of the strip about x-axis, about x-axis should be equal to area multiplied with the distance from the axis. Okay, that should be equal to, area is B dy and the distance is y, so this should be distance square, y square. Okay, now this is the moment of inertia of this strip only. We have to find out the moment of inertia of the whole area. So we have to integrate this quantity. So moment of inertia of the whole section whole section should be denoted by I suffix xs. That should be moment of inertia with respect to xs axis. It should be equal to integration of this quantity. This is the by square dy. by square dy. Okay, and the limit should be equal to minus d2 to plus d by 2, sorry, minus d by 2 to plus d by 2. That is the distance of this. This should be the distance, this distance should be d by 2. Okay, this is the upper side of the x-axis, so it should be the plus d by 2. Similarly, the lower section, the lowermost section should be minus, at a distance minus d by 2 from this axis. So the limit should be here minus d by 2 and here plus d by 2. Now integrate this quantity, that should b is constant, and integrate of y square, that should be equal to y cube by 3, and the limit should be d by 2 minus d by 2. So it should be equal to b into d by 2 cube to the by 3 minus d by 2 cube by 2. Okay, that should be equal to bt cube by 12. Okay, that should be directly written as bt cube by 12. Okay, you can simplify at home and find the simplified form is bt cube by 12. So the ixx, that is moment of inertia, is equal to bd cube by 12, and this is the moment of inertia with respect to x-axis. Similarly, if we find the moment of inertia with respect to y-axis, the value should be db cube by 12. Okay, and if it's a hollow rectangular section, if it's a hollow rectangular section, then the section should be like this. This is the depth. This is the hollow rectangular section. This is the hollow rectangular section. This is the depth, this is the width. Okay, and this is also depth, that is denoted by d1, and it is the width, that is denoted by b1. Okay, now the CG is here, that is the at a distance of d by 2 from the top or bottom, and at a distance of b by 2 from left or right side. Okay, through this CG draw a axis parallel to its base, that is x-axis, and through this CG draw a axis parallel to its side, that is y-axis. Now the moment of inertia with respect to x-axis of this hollow rectangular section should be equal to, that is, previous equation was bd cube by 2, the equation should be equal to bd cube by 12 minus b1 d1 cube by 12. Similarly, y should be equal to db cube by 12 minus d1 b1 cube by 12. Okay, now if some numerical is given, the data of depth, width, and the value of d1 and b1, you can easily find out the moment of inertia with respect to x-axis or y-axis from these equations. Okay, just put the value of depth and width and calculate this value. Now one thing I forgot to say you that what is the unit of the moment of inertia of plane area. Unit of moment of inertia of plane area. The equation is summation of a r square. The A area has the unit length square and R has the dimension L whose power is 2. So this unit should be has a dimension L to the power 4, length to the power 4. So the unit of the moment of inertia plane area it should be equal to millimeter to the power 4 or meter to the power 4. Okay, so please cautious about the unit given in your problem. It may be some unit in meter, some unit in millimeter. So first changes of all the unit in either millimeter or meter, then calculate, and the final unit of the moment of inertia should be millimeter to the power 4 or meter to the power 4. If the value in millimeter to the power 4 is higher, then you can convert this value to the unit of meter to the power 4, and it's very simple.